Good morning, students. Today let us continue with our topics related to cloud computing, and we were discussing about the different services provided before this, and now we'll continue with virtualization. The basics for this topic were covered in the last week's session, that is basics of virtualization. Today what we'll be covering is about types of hardware virtualization. So this is the brief outline for today's session. We'll be considering about virtualization. We'll be talking about types of virtualization, that is hardware virtualization. We'll be talking about full virtualization versus para virtualization. We'll be also discussing about emulation virtualization. We'll be seeing the advantages of virtualization in cloud computing, also followed by disadvantages, and we'll be seeing certain assignments which are important from GTU exam point of view. So virtualization, as you have studied in the last class, is basically creation of something that is virtual rather than actual. Virtual is something like you see in the movies, like that is 3D, somebody in a 3D movie throws something at you and you feel it is coming towards. So that was basically the introduction of virtual things when it started. But with respect to cloud, you'll be talking of virtual devices. You'll be talking of virtual hardware. That is what we'll be studying today. So virtual of something that is not actual. Like for example, in cloud you'll be having a server, a desktop, a storage device, an operating system also can be virtual. When you talk of virtual machines, the OS installed in that guest OS is actually a virtual operating system, and certain network resources. Like for example, virtual networking is a example for network resources under virtualization. Now, as you can see in the diagram, this is depicting the virtualization in cloud computing. On the lower side, you can see there is the physical hardware, like you have the CPU, the RAM, the disk, and the NIC, which basically stands for Network Interface Card. Above that, you have the hypervisor, which helps in creation of virtualization layer. So you have various types of hypervisors which we saw in the previous session of basics of virtualization. So above hypervisor we have the virtual hardware. Now this is basically the focus of today's session, virtual hardware. As I said, hardware of virtual, the physical devices which are on the lower side, that is going to be termed as the virtual hardware. It's actually a quota from your physical hardware. Above the virtual hardware, you have the guest OS, and above that, you have the application. So this guest OS is installed onto the virtual machine whenever the virtual machine is created, and the applications are also installed on it whenever once the OS is installed on it. So applications are always above the guest OS. So this is a form of or a type of virtual machine which is also called as a virtual instance. So here in the diagram we are seeing there are three virtual machines with their independent guest OSs and the independent applications, and which are running actually with a virtual hardware which is actually on based on the host machine's physical hardware which is on the lower side. So this is brief idea about virtualization. Now let us see about the types of virtualization, that is hardware virtualization. You have full virtualization, you have emulation virtualization, and you have para virtualization. Now let us see about full virtualization. Full virtualization is in which the operating system which we saw is installed above the hypervisor is unaware that it is in the virtualized environment. It actually feels it is directly interacting with the physical hardware. Actually it is not interacting with the physical hardware but with the virtual hardware. So hardware in this case is, as I said, virtualized in the operating system, that is the host operating system, so that the guest can issue commands to which it thinks it's actually hardware. So the guest OS is issuing the commands to the virtual hardware, but actually it is feeling that it is interacting with the actual hardware. So but really these are just simulated hardware devices that are created by the operating system. So I'm repeating again, the guest OS feels that it is interacting with the actual hardware, but actually it is interacting with the virtual hardware. This like is an example which I said has hardware on the lower side, the host OS and the hypervisor. So up to this was common and is going to be common with most of the virtualization devices. Above that we have 3 virtual instances that are created and they have their guest OS. Now this guest OS is unaware that it is in a virtualized environment. It actually feels it is directly interacting with the hardware, but it is actually interacting with the hypervisor and then the devices which are giving a virtual feeling. So the guest OS, above the guest OS are the user softwares, various application softwares that are needed by the specific client, which can be provided by the service provider. Now this is emulation, simulation or emulation virtualization. So in this case the virtual machine simulates the hardware and it becomes independent of it. So the guest OS in this case does not require any other modification. So in some of the virtualization some sort of modifications are needed. So common use of emulation include the running of an OS on the hardware platform for which it was not originally engineered. So there are some things which do not work properly with respect to virtualization. So in such case they have to be engineered appropriately. So the hardware also needs to be done accordingly and also the OS needs to be modified accordingly so that they work on this specific hardware. Now then you have the para-virtualization. In such cases, it does not need to simulate hardware for the virtual machines. Guest OSs are executed in their own isolated domains. So every guest OS has its own domain and it is unaware of the other domains. That is why it is termed as isolated domains. The virtualization requires the guest OS to be become aware of the hypervisor. So in which case it needs to be installed appropriately. So hypervisor is installed on the physical server, that is termed as the host, and a guest OS is installed into the environment. Now as per the discussions, as I said, hypervisor provides various commands and these commands are basically sent from the OS to the hypervisor and that is called as hypercalls. So here as the hypervisor is interacting with the OS and the virtualized environment and the hypervisor becomes an intermediary layer and it is executed through the hypercalls. So hypercalls are basically used for managing the memory which is on the physical hardware of the operating below the operating system of the host machine. Now here you can see this is an example or a picture depicting para-virtualization. On the lower side you have the physical hardware, you have the hypervisor. The hypervisor is interacting with the shared physical hardware. We are discussing about types of virtualization, that is hardware. So here this is a shared physical infrastructure which we saw in the previous diagram had the CPU, the memory, the NIC card and various other devices. So that is there on the lower side. On the above is the hypervisor, as I said, and the hypervisor has the virtual machines on the above side in which the guest OS needs to be modified. So guest OS specifically in para-virtualization needs to be modified. So guest OS, once it is modified, it makes calls to the hardware through the hypervisor and that is called as hypercalls. So hypercalls, as I said, is used to manage the memory. This is the difference between full virtualization versus para-virtualization. So in full virtualization, basically the cost is comparatively reduced and the requests are separated from the physical hardware that facilitates these things. So whereas with para-virtualization, there is an enhancement of virtualization technology in which the guest OS is recompiled. As I said, it is changed to install or during the installation of the virtual machine, or when it is installed within the virtual machine, that time the changes are made. So in full virtualization, that allows the guest OS to be executed independently. So guest OS which is installed above the hypervisor can operate independently or execute independently in case of full virtualization. Whereas in case of para-virtualization, guest OS needs to communicate with the hypervisor by using the hypercalls as we saw in the diagram. So with respect to full virtualization, guest OS system issues hardware calls to access the hardware. Whereas in para-virtualization, guest operating system can directly communicate with the hypervisor using the drivers. So there are set of drivers installed through which the guest OS can interact. Full virtualization, basically the performance is comparatively very low, whereas with respect to para-virtualization, the performance is comparatively pretty high. So these are some of the advantages and disadvantages of para-virtualization, full virtualization, and we'll be discussing a little bit about partial virtualization. So with respect to para-virtualization, the advantages it can be scaled efficiently. So scaling in the sense when more number of resources are needed, such scaling factor where the resources need to be increased can be managed very efficiently with respect to para-virtualization. Whereas the disadvantages is if there is a lot of workload, the performance varies, so it can degrade with respect to time. Then with respect to full virtualization, the advantages are offload timings are very task consuming. Matlab the offloads time consuming, a lot of task consuming tasks they are. Then you have legacy hardware might not be issued. So maybe it does not work with the legal hardwares which are not supporting basically such features. With respect to partial virtualization, it is basically easier to implement as shown in the slide, and the disadvantage is backward incompatibility with the backward compatibility. In short, when you have some machines which are of lower configuration or maybe of the lower versions, they are not compatible. So partial virtualization is not so very popular. And the next session will be discussing about types of virtualization, that is related to these specific things. Like for example, you have application virtualization, network virtualization, the storage virtualization, the server virtualization, and desktop virtualization. This will be seeing a little bit of detail in the next section. This section was basically related to hardware virtualization. This is related to a mix of hardware and some sort of software virtualization. These are some of the assignments for today's session. These are specifically related to hardware virtualization or types of hardware virtualization, discussion about full virtualization, para-virtualization, differences about emulation virtualization and full virtualization, advantages, and hypervisor. Of course, the hypervisor topic we have covered in the previous session. Previous session when we discussed about basics of virtualization. We discussed about Zen and other hypervisors. So this was it for today. If you have any queries, you can contact me at the specified email ID. Also, you can WhatsApp me if you have any doubts. And of course, we have doubt solving session on Mondays. You can also talk to me on Mondays also through Google Meet. Thank you for today.